Hello friends, in this video we are going so the first example is integration 0 to infinity sine bz upon z dz. To solve this integral we will consider this double integral, that is integration 0 to infinity e raised to minus xz sine of bz dx dz. Now if we integrate this integrand first with respect to x, then we will have, now here we are going to integrate first with respect to x, so we will consider z as a constant, we will treat z as a constant. So we can take this sine bz outside of this integral 0 to infinity. So this sine bz as it is. Now integration of e raised to minus xz with respect to x. Okay, so integration of e raised to minus xz, this is going to be e raised to minus xz divided by coefficient of x, and here the coefficient of x is minus z. Therefore, the integration of e raised to minus xz with respect to x, this is equal to e raised to minus xz upon minus z, and limits from 0 to infinity. Now, if we put the upper limit infinity, we will have e raised to minus infinity minus lower limit is 0, so e raised to 0, that is going to be 1. So if we put the upper limit first, that is e raised to minus infinity, and e raised to minus infinity is 0, so first term is 0, then minus sign and bracket. If we put the lower limit, that is 0, so e raised to 0 upon minus z. Now e raised to 0 is 1, so 1 upon minus z, so this minus and this minus, so we will have plus 1 upon z. So after solving this integral first with respect to x, we will have integration 0 to infinity sine bz, and from this we will have 1 upon z. So the value of this double integral is same as integration 0 to infinity sine bz upon z, that is integration 0 to infinity sine bz upon z dz, and this is the integral we are going to solve. So we have see that this integral is same as this double integral. So firstly we have integrate this with respect to x. Okay, now we will integrate this integrand with respect to z first. Okay, so integrating with respect to z, we will treat x as a constant. Now we are going to change the order of integration, that is we will consider dz dx. So we will integrate this e raised to minus xz sine bz with respect to z first. So here we are going to use the formula, that is integration e raised to ax sine bx dx, this is equal to e raised to ax divided by a square, that is coefficient of x, plus b square, that is coefficient of x in the sine term, into bracket a sine bx minus b cos bx. So here we are going to use this formula in this one. Okay, so with respect to, we are going to integrate with respect to z first. So using this formula we will have this e raised to minus xz upon x square plus b square, that is here the coefficient of z is minus x. Okay, so this e raised to minus xz upon coefficient of z, that is minus x square, plus coefficient of z in sine term, that is b, so b square. So the term will be e raised to minus xz upon x square plus b square into, here we have a sine bx minus b cos bx. Okay, so similarly in the bracket we will have this minus x sine bz, then minus this b cos bz. Okay, simply we have used this formula. Okay, So integrating this first with respect to z, we will have this integration 0 to infinity as it is, and integrating that integrand with respect to z first, we have e raised to minus xz upon x square plus b square into bracket minus x sine bz minus b cos bz, and limits from 0 to infinity. Now if we put the upper limit infinity, we will have e raised to minus infinity, and that is going to be 0. So 0, then minus sign. Now now we will put 0. So e raised to 0, that is going to be 1 upon this x square plus b square as it is, into, if we put 0, then this sine 0, this is going to be 0, and here this cos 0, that is going to be 1. So we will have minus of b. So this minus sign and this minus sign. So we will have b divided by x square plus b square. So by putting the upper limit minus lower limit, we will have b upon b square plus x square. And now the integration of this b upon b square plus x square, this is equal to tan inverse of x by b. Since integration of 1 upon a square plus x square dx, this is equal to 1 by a tan inverse of x by a. So simply we have used this formula here. So this is equal to tan inverse of x by b, limit from 0 to infinity. So by putting the upper limit first, that is tan inverse of infinity, and that is going to be pi by 2 minus lower limit. So lower limit is 0. So tan inverse of 0, that is 0. So the answer of this is going to be pi by 2. And the value of I here we have got is integration 0 to infinity sine bz upon z dz. Therefore the value of this integration, this is going to be pi by 2. So the value of this integration, that is integration 0 to infinity sine bz upon z dz, this is equal to pi divided by 2. Now the second example is integration 0 to infinity, 0 to a 1 upon a raised to n minus x raised to n bracket raised to 1 by n dx. Now to solve this, we will put x raised to n equal to a raised to n sine square theta. So if we take nth root on both sides, we will have x equal to nth root of a raised to n, that is a raised to n raised to 1 by n. So this n gets cancelled. So we will have x equal to a into nth root of this sine square theta, that is sine theta whole square into 1 by n, that is going to be sine theta raised to 2 by n. So by putting x raised to n equal to a raised to n sine square theta, we have x equal to a into sine theta raised to 2 by n. Now from this, if we differentiate, we will get dx equal to this a as it is. Now integration of sine theta raised to 2 by n, derivative of sine theta raised to 2 by n, that is going to be 2 by n sine theta, and in the power 2 by n minus 1, and multiply by derivative of sine theta, that is cos of theta. So on differentiation, we get dx equal to 2 by n a sine theta raised to 2 by n minus 1, and derivative of sine is cos theta d theta. Now check the limits. When we put x equal to 0, this a raised to n sine square theta, that is going to be 0. So this implies sine theta is 0. So sine theta equal to 0, this will imply theta will be 0. So when x is 0, theta is going to be 0. And when x is a, then if we put a here, we will have a raised to n equal to a raised to n sine square theta. Now this a raised to n, this a raised to n gets cancelled. So sine square theta will be 1. So sine theta will be 1. So this implies theta will be pi by 2. So we have integration 0 to pi by 2, 1 divided by. Now if we put the value of x raised to n, that is a raised to n sine square theta here, we will have a raised to n minus a raised to n sine square theta, and if we take a raised to n common, then we will have 1 minus sine square theta, and 1 minus sine square theta is cos square theta. So a raised to n minus x raised to n, this is equal to a raised to n cos square theta, and whole this bracket raised to 1 by n into dx, and the value of dx is this one. So now in the denominator, the power of cos theta, this is equal to the power of cos theta is 2 by n, and here in the numerator there is one term of cos theta. So we have this integration 0 to pi by 2, this 2 upon n. Okay, so this is a constant, we can take it outside, and here there is a raised to n, and again raised to 1 by n. So this n gets cancelled, so we will have a in the denominator, and also there is a in the numerator, so they will get cancelled. So we have 2 by n integration from 0 to pi by 2 sin theta raised to 2 by n minus 1, and cos theta raised to 1 minus 2 by n. Since in the numerator the power is 1 and in the denominator the power is 2 by n, so the power of cos theta will be 1 minus 2 by n. Now we have seen this form earlier, that is integration 0 to pi by 2 sin theta raised to p cos theta raised to q d theta. Okay, and the value of this integral, this is equal to 1 by 2 beta of p plus 1 divided by 2 comma q plus 1 divided by 2. So using this formula here, the value of this integral, this is going to be 1 by 2 this 2 by n as it is. So 1 by 2 beta of p plus 1 divided by 2. So here p is 2 by n minus 1. So plus 1 means minus 1 plus 1 gets cancelled, and divided by 2. So this 2 will get cancelled. So beta of p plus 1 divided by 2 means beta of 1 comma n comma q plus 1 divided by 2. Now here q is 1 minus 2 by n. So q plus 1, so this is going to be 2 minus 2 by n, and q plus 1 divided by 2 means 1 minus 1 by n. So we have beta of 1 by n comma 1 minus 1 by n. Now this 2 gets cancelled, so this is equal to 1 by n, and if we use the relation between beta and gamma, this is equal to gamma of 1 by n into gamma of 1 minus 1 by n divided by gamma of 1 by n plus 1 minus 1 by n. Now this 1 by n minus 1 by n gets cancelled, so in the denominator we have gamma of 1, that is 0 factorial, and 0 factorial is 1. So we have 1 by n gamma of 1 by n into gamma of 1 minus 1 by n. Now here we are going to use the Euler's reflection formula. Euler's reflection formula, that is gamma of m into gamma of 1 minus m, this is equal to pi upon sine of m into pi. So to use this formula, this m should be between 0 and 1. Okay, so here we have considered the n as positive integer, so 1 upon n, this term will be of course in between 0 and 1. 0 is less than 1 by n, and 1 by n is less than 1. So here we can use the Euler's reflection formula. So here the value of m is going to be 1 by n. So by using Euler's reflection formula, the value of this is going to be pi divided by sine of, here m is equal to 1 by n. So m into pi means 1 by n into pi, that is pi upon n. So finally we have the answer of this integration, that is integration 0 to a 1 upon a raised to n minus x raised to n whole raised to 1 by n dx. This is equal to pi divided by n into sine of pi by n.